I'd like to give a big shout out to Dale Francis for getting this addition of this isIterable predicate function into Crocks. And it does exactly what you think it does. So if we were to call isIterable and pass it in iterable type, such as an array, or we could even do a string, or we could take this gen that we have that's actually a generator, an iterable based off the generator function count. And just to make sure that, yes, this is actually a generator, let's just use the generator API. We see we get 0, bop, 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 and we get it all the way 0 to 4. So this is the first step. Oh, I'm sorry. And also if we pass in something that isn't, such as a Boolean, then it's going to return false, and a number, of course, will return false. So anything that does not implement the iterator API is going to return false for this. This is the first step in a much bigger issue to where we're going to start allowing iterables in the places of arrays in some of the functions where it makes sense to do so. This will also lead to a brand new function called take, which will take a specified amount from any iterable. So yeah, another shout out to Dale Francis. Thanks for getting this in. This next fix was reported by, I'm probably going to butcher this, but at Johan Codenha on GitHub for finding this. And what was going on due to a recent change or another bug fix that we had, it exposed an issue with how we were doing our promises and hooking up async to promise. The bug that happened is it would create or allow for errors to actually be absorbed or swallowed whenever it was started with a promise. So any errors that happen in any subsequent computations would be swallowed up. So just to demonstrate, we're going to stay on the old crusty version here. And we just basically have this simple fork function here. And you'll notice what should be going on is it should be reporting this error. So we do our from promise, which is basically just going to do a promise.resolve. And it should, once it hits this mapping on this error, it should throw this error, huh? But as we see here, it doesn't. And that's bad news bears. Just to see that, yes, this is hooked up and should be working, let's go ahead and get rid of these logs. Notice how we're getting the res, and it resolves to actual 33. If we come here and map it, it should be throwing an error, but it didn't. So the fix for this was put in by Karthik. Thanks again, Karthik. We got this in. And let's switch over to the new hotness here. And we'll notice that now it throws the error as expected. Now, why is this a breaking change, you might wonder? Before, we had a little regression that was introduced with the last fixed. And what should have happened is it should have errored. But it was erroring inside of the promise and being caught and would actually reject. And that's not the behavior that was intended. So because of the way the old bug was, it was taking errors that were in a promise and actually rejecting them when it should have crashed the app. So now this has been fixed up to the original intention where it will actually crash your app. So the reason why it would do that is, and it would only happen in the computation, notice this is a JavaScript function. If I were to just call error without this, it would actually crash the app. So if I do error and call it, notice I get the error being thrown. So it needs to actually have that same behavior inside of the promise. Now, it's not exactly the same because a promise, of course, is going to, it's going to be a different error, basically. But the effect of it crashing your app, that is still going to be in play. So ways you could get around this is by chaining anything that could error in a computation using a result or using try catch. So if we come here and just to show you what this could look like, we'll do a try catch. And we're going to change this from a map. And we'll also, because we are going to be in an async, we need to bring in a natural transformation. So we'll do result to async. And now we can take this function and we'll jump down here, change this to a chain, and then we'll do, Oh, let's see here. We'll do try catch, or I'm sorry, we do result to async, and then we do try catch with error being the thing that we want to do. So, oh, sorry. Now when we get into that, we see that it happens with the rejection. And that's because we were able to lift this actual try catch here and run it to where it would capture it in the result. So we're basically, if we were to take this try catch and we'll say, I don't know, we'll do const fn equals try catch, and then we do our error. We notice that we now have this function, and if we do log fn, and let's go ahead and pass it, well, we don't need to pass it anything. We see, oh, sorry, this is still showing up. Goodness gracious, let me comment that out. We see that we get the error, huh? So it's the same thing, but now, since this is working this way in JavaScript, we can then do this natural transformation and lift this flow and actually merge it into the fork itself or into the async itself by using this natural transformation. So yeah, that's how you'd get around it. And that's all I have. I'd like to give a shout out to Matt Ross for his first code contribution to the Crocks library. And his contribution is this converge combinator. This is basically the Starling Prime or Phoenix combinator. It takes 3 functions and then a value and then returns the result of applying that value to this combinator. So the first thing is going to be at least a binary function that takes a B, then a C, and returns a D. The second function you provide takes an A to a B, and the third function takes an A to a C. Finally, we take the A, apply it to all of this, and then return the resulting D. And what's going on is it's going to work in parallel, and it's going to take that same object, perform this change on it, take this object, or take the same object and perform another change on it, and then you can merge it together with your first function, which will take the B and the C and then return the D. A really complicated, contrived example of this is a safe rename function. And this function is going to take the string of what key we want to rename, then what we want to rename it to, the actual thing that we want to perform the operation on, and it's going to give us back a maybe of object. The reason why this is a maybe is that key may not exist, or it may not even be an object that you pass to it. But if the key exists and can be renamed, then we're going to go ahead and give you back a maybe object. So we're going to use converge to do this. And all we're going to do is create a function that takes the string, then the other string to name it to, and then the other parameter will be applied to converge. What's going to happen is it's going to run it over this safe emit function, which is going to check to see if it's an object, and if it is, it's going to emit the key that we want. In this case, we're passing the from. So now on the left side of this, we have an object that is missing that key wrapped in a maybe. Also, we'll use this prop app function to do the actual renaming. And what this will do is pull the actual value off of the object, and if it exists, will then be mapped over into this object of, which will now lift it into a new object. And then now we apply our binary function, which will lift both of these applicatives and then, or lift in a sign and apply it to both of the functions on both the left and the right, resulting in a new object. Well, a new maybe wrapped in object. So to see how this works, we can go ahead and we'll just delete this and we will call rename, and let's rename A to be ID. And then here we'll go ahead and take in our data, and we see we get back a just where A has been renamed to ID and B is Bobby. Well, what if we want to take B and then rename that to actually be name? We see that we get back a new just that has name, has Bobby, and then the A is left alone. Why we're having this as the applicative inside of the maybe and doing the apply there is, what if we provide something that isn't there to rename? Well, now we get back a nothing because that doesn't exist. Maybe we change it back and change this to ID. And now let's go ahead and pass in an array. An array is not an object, so it's nothing is ever performed on it. Notice there's no errors that happen. Same thing if we pass in a Boolean. It has to be an object. So again, thank you, Matt Ross, for adding this addition, and I hope this finds its way inside of some of your projects. I'd like to give a shout out to Neon Flux for submitting an issue that the Crocks const functor did not properly respect the monoid constraint on the applicative. And they were 100% correct in this. To see what was going on, we'll use the old crusty version of const. So we'll make an M that is const. And the way that it worked before is it would point to the type of the original value that you passed in. So if we did this with M, we would see that M actually gave back a const of true. And if we mapped over it with, let's just make a negation function here. We'll do not equal and we log. Notice that it always stays to that. Also, if we then, put it to a type, or say we want to move this type to a toString, so we would expect this to move from a number to a string type, toString. Notice that it always stays with the original value. So that's because the const functor was supposed to or should point to one type and then map all morphisms on that type to the identity of the type that it points to. So any subsequent maps or changes to that, all of those morphisms should point right back to the identity on the type that we're pointing to. So this is how we keep getting back the 56. But if we look here, when we do AP, we should not be allowed to do that. Oh, because we have the const. We should not be allowed to change types or anything like that. So say we then make a new const of string, that shouldn't be allowed because string isn't the same type as that. It just didn't work out right. There was a lot of problems with that. So we changed it up to actually work more like the const functor should work. So to see what it does now, there's a lot of changes to this. We'll bring in the new hotness. And now we'll see that we get a type error because we need to actually give it a value to point to. So instead of an instance constructor, const is now a type constructor that requires you to give it a constructor or a type rep to actually get your instance constructor. So if we do this with nomconst, we'll call it nomconst, and we will go const to number, and this is just your normal JavaScript constructor. And then if we go here to numconst, we see that we get back a const that's fixed to number. If we were to put in a string or anything like that, that's actually a type error because it doesn't match the type that's pointed to for the instance itself. Now if we do a map over it, that's going to behave just the way that we would expect it to behave. So we'll just do x and we'll do x.toString. And of course, it's going to map this morphism to the identity morphism on number itself. So it's going to keep our instance of 56. Now, this is where the first breaking change comes in. So AP is not allowed to, actually, before we even check the type, if we were to do number const of 56 on AP, this should throw an error because in order for AP to actually work, it needs to be fixed to a type of semigroup. So what if we change this to a sum const, and we'll go here, do the same thing there, and the same thing there, but now we fix it to sum, which is a monoid. Now we take sum. When we construct it, this needs to be a sum of 56 because we have to provide an instance of the type that we're pointing to. And if we AP with sum on 56, because we're APing, we are actually able, and we're doing it with a semigroup at the very least, we're now able to, we know that a certain function does exist other than identity. And that function, of course, is going to be concat. So we're able to concat this just like we would normally when we call AP. So if we give this a save, sum const sum AP, hold on, what is going on here? Oh, and this needs to be a sum const, sorry, with a sum of 16, and we'll just paste that in there. So now we see that it does actually do the concatenation. The other thing is once we have a monoid, we can actually get the full applicative. That's just the apply. We can get the full applicative now on a monoid type because we are able to, let's do sum const. We can call of, and we can make it from nothing because we know what to point it to. So we can make it of any type string. And of course, that's going to map it down to the empty of this and continue to be the empty. So from here, we can now use concat or AP. Both of them will work. Concat or AP, and this will be a sum const of, we'll say 10. And it needs to actually be a sum 10 because we have to go with the instance here. And that gets us back a sum 10 because of the identity laws on the monoid. All right. One last thing. Say we have a semigroup and not a pair. Say we have a semigroup but not a monoid, and we have that with pair. Pair is a semigroup if both the left and right side, or the first and second, are semigroups. So then it can just call concat on it. So if we were to go here, we'll do pair const, and here we'll do pair const. Notice we don't get the of because it needs to be fixed to a monoid. But we can, if we make an instance of this, and we'll just say pair, and we'll put an array that has 6 in it, and then we'll do a sum of 22. We give this a save. We notice that we get the pair with the sum of 22, all of that. But we can use AP on it because it is a semigroup. So if we just take another instance, if we just take another instance of this, we'll go here, v to the end, paste that in. Then we can say replace this to, replace this to 5, and we'll do a sum of 2. We see that it works as expected. So yeah, these are the changes. If you were using const anywhere, the other change is chain did not make sense. We did have chain available before, but it really did not make sense. So if you try to call chain with something, it's going to tell you that it's not a function. So chain was also removed. That's all I have on this. Hope this all makes sense. Would like to give a solid whoop whoop to Karthik for this fix-up that he did on the try-catch function and how it deals with its arity and currying. A lot of times, the functions that you want to send to a try-catch are things that you may or may not have to curry. There might be just a, just some function that you're pulling from some library or something. And if we go ahead and let's look at the old crusty version of this, we'll take try-catch. Say we want to go ahead and we'll do add with 3 and 4. The way try-catch was before, it only worked with unary functions. So it would basically send this 3 to it, and then of course 3 plus undefined will give you back a nan. And to make it worse, if you tried currying this or doing anything like that and, working in a typical Crocks flow, then you're going to actually get errors when you try to do that because OK nan is not a function. Or the result that comes from that is not a function. So what Karthik added was the ability for this to work. So we'll now go hotness, pull that off, and if we save it, we see we get back our OK of 7. And it also works with the non-curried. So it works just like the normal Crocks curried, and you could pass it a non-curried function of n arity, and it will go ahead and apply things just the way that we would expect it to. Also, just to see that this still works, we will do a throw new error, and we'll just do a message of oops, oops. And then when we go to run it, we see that it is caught in the result, and it gives us an error of error oops. So again, I appreciate it, Karthik. Some adjustments were made to the index files that are used in the individual folders in the Crocks library in preparation for getting us ready to move to JavaScript modules and to also get the organization right for our repo. We're moving to a mono repo for version 1.0 and going to provide a lot of this functionality in its separate packages. As such, we've noticed that some people might be pulling directly off of the index files. Like in this, if we look at this old crusty version here, we could see that we're pulling off from this will become, Crocks/helpers. And then, of course, is going to give back the index file on that, which we're going to go ahead and destructure prop off of it. So I'd like to advise from not doing this, because as we move along, we're going to be changing what those index files are. If you need to reference things directly, it's highly recommended to do things like, if we want prop is actually not part of the normal helpers package. It's going to be part of the maybe package. So you're going to want to do something more along the lines of this. So if you had Crocks and then we'll just do maybe and then bring in prop directly like that, that's going to be better suited. So for instance, this breaking change that we did was moving all of the functions that belonged in other packages off of that index and just keeping them inside of their package. So if you find yourself doing something like this, you want to move away from it and go more to something like this. So in the old crusty version, you would see that prop indeed is the prop function. If you were to pull it off of the index file in helpers. So we would do prop A and then pass something in a true, and this should get us back a maybe of true. And if this was B, that of course would give us back nothing. So we know that this is the actual prop. If you're going to be for, smaller builds, things like that. Also, this breaks the way that ESM is working, or the modules are working, because we are just exporting an object and not doing an actual export here. So if this were to be an actual like import from, that's not really going to work, because under the hood, it's still a common JS interface. So again, it's not recommended for that as well. Eventually, it will work the way that you're thinking, but not in this version. We're going to have to wait till version 1.0 to get that stuff in. But if you'll notice, this same way, and we're just doing the Crocks to maybe that there, we can now do prop and say we do A again with an object of A, and we'll do 56. Notice this still is the same prop function. So this is the way you're going to want to bring it in. So how did we break this? Because we removed that, prop it's supposed to be referenced from the actual maybe package, or will be the maybe package that you bring it in and install on your system. So how you would, like right now, if you're pulling off of the index, if we move this over to the new hotness, and this is just, on my local box here, you'll see that it's actually undefined. And that's because it's no longer there. But if we were to take it from, say, maybe, and then we do maybe prop.js, then, and bring it in like this, this is the actual function here. So if you find that you were doing that, you're going to want to move over to a pattern more like this, because it is going to break your code as soon as this goes out. All right, thank you. That's all I got.